have you, wonderful math students. This is Miss Berger, joined by the handsome and incredible...
Coming in from the side like always, Mr. Lamb.
Mr. Lamb, and today we're going to talk about proportional relationships. Really, the different strategies we can use to figure out if two ratios are equivalent, which means they are proportional.
So the only thing we're really trying to figure out is if we have two ratios, are they equal to each other?
Yes.
Okay, I'm good then.
Super simple, right? So, our learning target, I can identify proportional relationships between two ratios, right? Two or more.
Sounds like what we just said.
Sometimes there's more than two, if you're looking at a table. So there's 4 strategies that you can really use to identify if two ratios are proportional, right? 4, I mean, there's probably more than 4, but 4 main ones
that we
for
use
sure,
most of
that
the time.
we use most of the time. Now remember, you do not have to use all of them for every problem. They're kind of just tools in a toolbox that you can bring out when you get to one that maybe is not as obvious.
But you might want to write these down while she's writing them down, just so that you know what the 4 are.
That's right. Number 1, convert to a decimal, right? So if you have a ratio written kind of like a fraction and you make it a decimal and you check the second one and they have the same number, the same decimal, then they're equivalent.
Yeah, just like you would do if you were doing, fraction, decimal, percent, right?
Which we've already done.
Which we've already done, so you know how to do this.
So we know how to do it, right? The second strategy is to find a common multiplier. So we did that a lot when we were looking at ratio tables. Multiplier. Sorry if it's taking so long. But you're taking notes too, so it's fine. So find a common multiplier, right? If every line in a ratio table is being multiplied by the same number, then the whole table is proportional. So, or we could what we do called cross multiply. This is also known as the butterfly effect. So when you cross multiply, if the diagonal products are the same, they're proportional. Sounds complicated, but it's super easy.
Yes, it is.
And the 4th strategy are double number lines that you can use to show multiple equivalent relationships or proportional relationships.
And double number lines are going to seem a little confusing when you first start out with them.
Yeah.
But once you understand how this number line and this number line interact with each other, it's really a great way to do things that are looking for multiple answers.
Right, those choose alls, that double number line comes in handy. So let's put some of these into practice. And let's start by looking at common multipliers.
I'll start with mine.
Okay.
Okay, now when you look at this table and you're looking, right away they say, hey, you need a common multiplier. When you look at it, you might look at it and go like 6 and 21. There's no number multiplied by 6 that's going to give me 21. That's why they give us the handy dandy pocket calculator.
That's right, or your Desmos.
Yeah, or your Desmos on anything. Okay, so 6 to 21. Now it's going to sound weird because to find a common multiplier, I got to divide.
That is weird.
Yeah, it is. But so I'm going to take the big number.
The big one.
Oh, you got to give me something to
sorry.
write with. It's okay. You got to take this number here, the big number, and you're going to put it in your calculator, 21. And then you're going to divide it by the smaller number, 3.5, which means if 6 times 3.5
is 21.
equals 21. So my common multiplier is going to be times 3.5.
Well, we hope, in order for it to be a common multiplier, every line has to be the same.
Can I check just like a couple of these?
No, you have to check them all.
Okay.
Because remember, mean teachers are test makers.
Probably that one is the one that's going to be wrong if any of them are, because that's what the teacher would do.
That's right. So, is 8 times 3.5 28?
It is.
It is. Is 12 times 3.5 42?
It is.
It is. Is 16 times 3.5?
Now, if I was making the test,
56.
that's the one I would mess up.
Yeah.
So 16 times 3.5 is 56.
Is 20 times 3.5 70?
Well, this one I happen to know because 2 and 7, 3.5.
That is true. So that means that 1, that is a true ratio table because each line is being multiplied by the same number.
And are you allowed to use a calculator for this?
Yes.
Not only are you allowed to use a calculator, we highly recommend it.
Highly recommend it. Speaking of calculators,
you may have it.
Let's look at this side. So this side, the common multiplier is already kind of done for us. This is not a traditional thing. This is an example that shows that to get from 5 to 2, I have to multiply by that fraction, by 0.4.
Well, that's weird.
Or 2/5. Well, yeah, if your number's going down from
It
left
has
to
to
right.
be a number less than 1. That would make sense.
Yeah, so you're multiplying by a decimal, right? So, but I want to show you the convert to decimal strategy, right? So we already see that this clearly is a ratio table, and these are all clearly equivalent, which means they're proportional. And we have that each line is being multiplied by 2.4. Oh, sorry, 0.4, not 2.4.
Yeah, that would be bad.
So, say that those weren't there, because clearly they're not going to really be there. So say I wanted to go from 5 to 2, and I'm like, I don't know. So let's do on our calculator 5 divided by 2. Well, I get 2.5. Hold on.
So
let's do it. Don't you know?
No, I was just going to show them that what the fraction looked like, and then what the decimal looked like.
I think they got it.
I'm just making sure.
Gosh. All right, so let's do
So
10 divided by 4, which is 2.5. And then let's do 30 divided by 12, which is 2.5. And then 2.5 divided by 1 is 2.5, right? Okay. So because all of them have the same decimal, boom, equivalent.
So just turn them into a fraction,
drop the mic.
Make them into a decimal.
Right. Left divided by the right. And even if this one's smaller and this one's bigger, you'll get like a true decimal. Like
yeah, you'll get like something less than 1.
Yeah. All right, so 2 strategies. Common multiplier, convert to decimal.
Like it.
Boom. Nailed it.
Ooh, this is actually my favorite.
So we'll let Mr. Lamb take the wheel on this one, because if not, he's just going to talk over us anyway.
That's probably a pretty true statement. This is my favorite, right? Because this is called the butterfly thing. I had this thing about butterflies anyway. So cross multiplying. What do we mean by cross multiplying? Well, cross multiplying means I'm going to take these two numbers.
They're diagonal from
Ooh,
each other.
it looks like the wings of a butterfly.
Right.
Ooh, look at that.
And
oh no, I didn't do very good at my 27.
What happened to that wing?
That wing kind of died.
So what you do is you take those two numbers across from each other and
So
multiply
17 times 81 equals?
Is 1,377.
Wow, good thing we have a calculator to use.
That's right.
What's 51 times
27 is 1,000.
So 51 times 27
is 1,377.
And if the product, the answer to a multiplication question, you guys remember that.
Right?
So if this product and this product are, I didn't think both right at the same time. That's awesome.
Yeah.
If this product and this product both equal the same thing, the relationship is proportional.
Yes, and if they don't,
then it's not proportional.
Then it's not. So simple, right?
So easy to see that, right? 1 over 2 equals 3 over 4.
Yeah.
This equals 4, but this
equals 6.
Not proportional.
No. Not equal to each other.
See how easy that is to do? That's kind of why I like it. It's nice and quick, and it's just cross. Later on, when we're finding like missing values, this is a great way to find a missing value too.
Yes, but there's a strategy for that. More to come.
We'll talk later.
All right, so let's look at double number lines. Oh no.
Hey, why don't you just quickly go fix that so they can read it?
Okay, hold on,
just
guys.
take a second. So I'm going to entertain you while she's doing that. See, like, I'm going to draw a butterfly. Oh, I can't because she just moved the thing. So I can't draw you a butterfly. Let's see, what can I do to make this? Oh, I think she's almost there. Thank goodness. We got to stop using that font.
I know, right?
There we go. Hey, I can read that.
Okay, sorry, guys.
It's okay. We make little mistakes from time to time. That's called learning.
Mistakes are part of learning. All right, so double number lines. This is a really cool strategy to identify a lot of equivalent ratios or proportional relationships. So this says, it's a word problem, so I'm going to read it. As Sincere is mixing up his tang for the camping trip, he notices that he needs 8 teaspoons of mix to 2 cups of water. His task is to mix enough for a container that holds 12 cups of water. Use the double number line to explain your answer. So I look at the numbers as kind of the original ratio, right, that they gave me. So I need 8 teaspoons for every 2 cups of water, right? So I'm going to make a number line that's counting by 2s and then one that's counting by 8. But it's important that you're lining up everything properly.
Yeah.
So I'll show you what that looks like. So this will be water. Oops. Sorry, forgive me. It's at least better than Mr. Lamb's. And this will be the teaspoons.
She picks on me when I'm not talking.
Teaspoons. Right? excuse the not so straight lines. So for every 2 cups of water, and we want to get all the way to 12 cups, right? So I'm going to do, okay, so 2, 4, 6, 8, 10. I'm trying to make it super nice and clear for you guys, right? So 2, 4, 6, 8, 10, 12. 12 cups of water is what I want to end up with.
So now when you go to do the other one, you're going to count by
eighths,
okay.
right? Because 2 cups of water needs 8 teaspoons of mix.
So we know this is proportional. Yeah. It tells us that.
That's true. And I'm going to line these up just as nicely as I can to create multiple equivalent relationships or proportions, right? So 8, 16, 24, 32, 40, 48, right? So the nice thing here, if this was like a choose all that applies, 2 to 8 would be the original ratio. 4 to 16 is equivalent. 6 to 24 is equivalent. 8 to 32 is equivalent. 10 to 40 is equivalent. And then the answer to my original question, if I have 12 cups of water, I need 48 teaspoons. That's a lot of teaspoons.
Double number lines are a great way to show different, show that relationship over a variety of inputs.
Right, and again, it's just a strategy, right? So if you're like, that strategy's not really for me, I'm not going to draw those double number lines, then for this, you could have used one of the strategies we did up top.
Yes, you could have.
Yeah.
But this is really an excellent strategy once you get to know how to use it.
Yeah, I love me a double number line.
Yes, you do.
I do. All right, so if you're kind of ready to go with understanding proportional relationships, start that classwork. If not, watch that next video. Love ya.